Pluto, once considered the ninth planet in our solar system, has long fascinated astronomers and space enthusiasts. Although it was reclassified as a dwarf planet in 2006, its mysterious nature continues to captivate researchers. Since its discovery in 1930, Pluto has inspired curiosity, especially following the groundbreaking data and images returned by NASA's New Horizons mission in 2015. Despite its small size and remote location, Pluto is a surprisingly complex world, with towering mountains composed of water ice, expansive plains of frozen nitrogen, a tenuous but layered atmosphere, and signs of intriguing phenomena like cryovolcanism, ice volcanoes that erupt frozen slush instead of molten lava. Pluto's discovery came in the early 20th century, when astronomers noticed subtle gravitational irregularities in the orbits of Uranus and Neptune, hinting at the presence of another planetary body. In 1930, Clyde Tombaugh, a young astronomer at the Lowell Observatory in Arizona, confirmed Pluto's existence by meticulously comparing photographic plates. Initially hailed as the ninth planet, Pluto's small size and highly elliptical, tilted orbit soon raised doubts about its classification. Unlike the other planets, Pluto's orbit occasionally brings it closer to the Sun than Neptune, and lies at a noticeable angle compared to the relatively flat plane of the other planetary orbits. These anomalies led astronomers to suspect that Pluto might belong to a larger population of icy bodies beyond Neptune. This idea gained traction in the 1990s with the discovery of the Kuiper Belt, a vast, donut-shaped region filled with thousands of frozen objects. Pluto was no longer an oddity, but rather the largest known object in this distant realm. Consequently, in 2006, the International Astronomical Union redefined what constitutes a planet and reclassified Pluto as a dwarf planet. The decision sparked widespread debate, but reflected an evolving understanding of the solar system's structure. Despite its reclassification, Pluto remains a scientific treasure trove. Its surface is composed of a mix of frozen nitrogen, methane, and carbon monoxide, creating a dynamic and reflective landscape. The most prominent feature is Sputnik Planitia, a massive, smooth plain of nitrogen ice that shows signs of ongoing geological activity. Surrounding this region are towering water ice mountains that, due to the extreme cold, are as strong as rock. Pluto also boasts a thin atmosphere composed mostly of nitrogen, with trace amounts of methane and carbon monoxide. This atmosphere changes dramatically depending on Pluto's distance from the Sun, sublimating when closer and freezing back onto the surface when farther away. One of the most intriguing mysteries is the possibility that Pluto harbors a subsurface ocean. Although long believed to be entirely frozen, New Horizons data suggest that a layer of liquid water may still exist beneath its icy crust. Surface features such as fractures and ridges imply internal activity that could be driven by heat from radioactive decay or antifreeze-like compounds such as ammonia. If confirmed, this would place Pluto among a growing list of icy worlds like Europa, Enceladus, and Titan that may have the potential to support life, albeit in extreme conditions. Another exciting finding from New Horizons was the evidence of cryovolcanism. Instead of molten rock, Pluto's potential volcanoes appear to erupt slushy mixtures of ice. Large domes and flow-like formations on its surface suggest internal heat may have allowed semi-liquid materials to reach the surface, further supporting the theory of an underground ocean. Pluto is not alone on its celestial journey. It has 5 known moons, the largest of which is Charon. Nearly half Pluto's size, Charon is so massive relative to Pluto that the two bodies orbit a shared center of gravity outside of Pluto itself, making them a binary system rather than a traditional planet-moon pairing. Charon's surface is made primarily of water ice and features massive canyons and cliffs that hint at a geologically tumultuous past. The 4 smaller moons, Styx, Nix, Kerberos, and Hydra, are irregularly shaped and are thought to have formed from debris after a colossal impact billions of years ago. New Horizons revolutionized our understanding of Pluto's surface. While scientists expected a heavily cratered and inactive terrain, they found a landscape constantly being reshaped. Sputnik Planitia, for instance, appears to renew itself through convection, a process where internal heat causes the nitrogen ice to churn, similar to magma in Earth's mantle. This ongoing activity, combined with features like water ice mountains and vast networks of ridges and valleys, points to a planet still evolving geologically. Perhaps one of the most visually surprising revelations was Pluto's coloration. Instead of a uniformly white, icy surface, Pluto displays reddish-brown hues and dark regions, largely due to tholins, complex organic molecules formed when ultraviolet light interacts with methane. These compounds settle onto Pluto's surface and give it a unique, rust-colored appearance. The existence of tholins raises tantalizing questions about prebiotic chemistry and the potential for life's building blocks in even the most remote regions of the solar system. Pluto's thin atmosphere adds another layer of intrigue. Composed mostly of nitrogen with traces of methane and carbon monoxide, it expands and contracts significantly over the course of Pluto's 248-year orbit. When closer to the Sun, surface ices vaporize, creating a temporary expansive atmosphere that refreezes as frost when Pluto retreats into the cold. Among the most striking atmospheric features observed by New Horizons were the layers of blue haze extending over 200 kilometers above the surface. These layers scatter sunlight similarly to Earth's atmosphere and contribute to Pluto's reddish surface color as they settle. Charon, while lacking an atmosphere, has its own fascinating geology. One of its most prominent features is Mordor Macula, a large dark patch near its north pole, likely formed from material transferred from Pluto. Charon's crust is marked by enormous canyons, some deeper than Earth's Grand Canyon. Though currently inactive, signs of past internal activity suggest it may once have housed a subsurface ocean that has since frozen solid. Meanwhile, the other four moons behave chaotically, tumbling unpredictably due to complex gravitational interactions within the Pluto-Charon system, behavior that is unlike anything seen elsewhere in the solar system. Pluto's demotion to dwarf. Planet status was not a dismissal of its importance, but a reflection of the broader discoveries about the Kuiper Belt and the nature of planetary classification. Alongside other similar-sized bodies like Eris, Makemake, and Haumea, Pluto is now viewed as one of many large icy worlds in a vast frontier that challenges our traditional view of the solar system. The potential habitability of Pluto, while speculative, is increasingly intriguing. On Earth, life has been found in extreme environments such as hydrothermal vents and subglacial lakes. If Pluto does possess a subsurface ocean, it raises the possibility that microbial life could survive there, shielded from the harsh conditions of space. Supporting this theory are the planet's active ice flows and relatively young surface, which shows surprisingly few impact craters, indicating recent geological activity powered by internal heat. The Kuiper Belt itself, stretching billions of miles beyond Neptune, is home to countless frozen objects that serve as time capsules from the solar system's infancy. After its Pluto flyby, New Horizons continued its journey and visited Arakoth, formerly known as Ultima Thule, in 2019. This contact binary object is one of the most primitive bodies ever studied, providing a glimpse into the building blocks of planets. Looking forward, scientists are already discussing future missions to Pluto and the Kuiper Belt. These could include orbiters that would study seasonal changes or even landers equipped to probe the composition of surface ices and search for signs of subsurface oceans. Though missions to Pluto are long and challenging due to its vast distance from Earth, over 3.6 billion miles, the potential scientific rewards are immense. In the end, Pluto's legacy extends beyond planetary science. It represents the evolving nature of exploration and our ever-deepening understanding of the cosmos. Whether classified as a planet or a dwarf planet, Pluto remains one of the most dynamic, mysterious, and scientifically rich bodies in our solar system. As technology progresses, the secrets buried in Pluto's icy depths may one day come fully to light.